All right, let's get right into it. Welcome, everyone. Today, we're doing a deep dive, essentially a strategic briefing built specifically for corporate decision makers and IT executives. We're going to completely unpack how to evaluate distributed ledger technology, blockchain for enterprise environments. Look, if your organization is eyeing this tech to boost transparency and operational efficiency, that's great. But understanding the exact security risks it either amplifies or eliminates is absolutely critical before you spend a single dollar.
So here's our roadmap for this explainer. We'll kick things off with a strategic executive summary, navigate the fundamental trade-offs of the blockchain trilemma, and then break down 18 very specific security risks. After that, we'll tackle application migration, run through a framework for vendor assessment, and wrap up by looking at how to guarantee active business continuity. Section 1. The Strategic Executive Summary.
To really set the stage here, we have to contrast how blockchain actually works compared to our traditional systems. Conventional databases are centralized and mutable. We all know them, we're comfortable with them, but they're inherently vulnerable to a single point of failure. Distributed ledgers, on the other hand, flip the script. They operate on a decentralized, trustless paradigm. They are immutable, meaning once data is in, it's not changing. But, and this is a big but, that decentralized nature introduces entirely new threats, like consensus-driven attacks or bugs that are just permanently locked into the code. It is a massive paradigm shift. So when you're evaluating this tech, the absolute first question you need to ask your team is this: do we actually need a shared, consistent data store? Because if the answer is no, you simply don't need a blockchain. The real use case only pops up when you have multiple entities who don't necessarily trust each other, but they all need to contribute to a shared environment without a central boss. If everybody already trusts each other perfectly, honestly, a well-managed conventional database is going to be your safer, much more efficient route. Moving to Section 2, navigating the blockchain trilemma. To truly grasp the security side of things, we have to start with the core technical analogy that's going to guide our whole assessment today, the blockchain's trilemma. It's basically a framework that explains the constant tension between a network's scalability, its decentralization, and its security. And for you as executives, the big takeaway is this: it's a zero-sum game. Increasing any two of these attributes will inevitably force a decrease in the third. Want a highly scalable system for massive transaction volume? Well, you're probably widening your attack surface or sacrificing decentralization. You literally cannot have all three maxed out at 100%. Let's look at how these trade-offs actually play out in the real world. First up, the lack of privacy. This comes from the natural conflict between transparency and privacy when anyone is reading the transaction history. Sure, transparency stops double spending, but corporate clients obviously demand privacy. The second big one is scalability. That's a direct result of the clash between security and speed when you're writing to the data store. If you use those heavy proof-of-work algorithms, manipulating the data becomes ridiculously expensive. So your security is sky high, but man, it absolutely cripples your processing speed. Ultimately, this blockchain trilemma dictates your entire risk surface. Grasping this underlying tension is absolutely crucial before we start picking apart the real-world vulnerabilities of new implementations. Because at the end of the day, every single architectural decision is a compromise. Section 3. Mitigating 18 security risks. Okay, now that we've got the tech trade-offs down, let's zoom in on the actual threat landscape. We've broken down the top 18 risks into domains. Domains 1 and 2 are all about how the network itself amplifies vulnerabilities. Take smart contracts, for example. We're talking about unchangeable code. If a bug is in there when it goes live, it's there forever. We also have to plan for a 51% attack. This is a wild scenario where malicious actors actually gain majority control of the network's computing power. They could literally halt or reverse transactions. It's a risk completely unique to decentralized networks. Then we have domains 3 and 4, which focus on operational and management risks. And what's really fascinating here is that we spend so much time obsessing over advanced cryptography, but investigations show that a simple lack of basic OPSEC, operations security, accounts for roughly 66% of blockchain incidents. So standard cybersecurity, asset management, and rock-solid InfoSec policies, they are just as crucial, if not more so, here. You simply can't forget the basics. Section 4. Application migration and privacy. All right, pivoting now from building brand new systems to what is honestly a bit of a minefield, migrating existing legacy applications over to a blockchain. If your team is attempting this, these top 6 migration risks need to be treated as hard toll gates in your project plan. You have to be dead sure you're picking the right blockchain,
public or private, you need entirely new contingency plans, and maybe most importantly, you have to prioritize simplicity in your smart contracts. It's a core security measure. The more complex the code, the higher the chance you've just deployed an unfixable vulnerability. Just let this sink in for a second. Once a chain is started, there is no possibility to test the code further to weave out bugs. Think about how different that is. In traditional IT, you deploy, you find a bug, you push a patch on Tuesday. On a blockchain, immutability means your testing has to be incredibly, obsessively exhaustive before deployment. The traditional software development lifecycle just gets thrown right out the window here. Which brings us to a massive, massive compliance warning. The whole appeal of a blockchain is that data is almost impossible to remove. But what if you publish encrypted, sensitive data to an immutable ledger today? Well, you have to be totally comfortable with the reality that tomorrow's computing power might crack that encryption. And if it does, that sensitive data is just permanently sitting out there, exposed to anyone on the chain. It's a genuine privacy compliance nightmare. Section 5, Vendor Assessment and Training. So how do we actually govern this? Here is your operational blueprint for evaluating potential vendors and locking down your supply chain. It's a simple, sequential checklist. Number 1, audit your subcontractors. Make absolutely sure your blockchain partners are explicitly covered in your legal agreements. 2, verify their controls. Do they actually have robust monitoring to tell you if a cryptographic algorithm gets compromised? And 3, enforce a right to audit clause. Even on a public chain where auditing is tough, you have to maintain visibility into your provider's security practices. But what about your own team? Internally, human resource security is where this all starts. You need rigorous employee screenings, especially for the developers writing those permanent smart contracts. You have to require specialized training, establish nonstop security awareness programs around DLT, and enforce a very strict separation of duties. Simply put, no single employee should ever hold all the keys to the kingdom. Section 6, guaranteeing active business continuity. We need to wrap up this briefing by facing the music. What happens when things inevitably hit the fan? This is probably the most critical failure point for corporate IT to wrap their heads around. In a standard public key infrastructure, if someone loses a password, you hit revoke, issue a new one, and grab a coffee. Not here. On a blockchain, if you lose the private key to your assets, there is no IT help desk to save you. It cannot be revoked or replaced. The assets, the data, it's all gone, permanently. The standard safety nets are gone, which means cryptographic key management requires an entirely new level of contingency planning. And when the network itself breaks, your business continuity plans have to anticipate completely unique scenarios. What if the network suffers a hard fork and suddenly splits into 2 totally incompatible chains? Or what if the network's computing power drops out of nowhere, slowing your enterprise transactions to a crawl? Your infrastructure has to be resilient enough to survive these kinds of decentralized shocks. Which leaves us with this final, essential question for you and your teams to ponder. Knowing the strict trade-offs of the trilemma, having to sacrifice speed for security, managing code you can never change, and dealing with incredibly unforgiving key management, is your corporate IT infrastructure truly prepared to handle the immutability of the blockchain? It's an unbelievably powerful tool for transparency and efficiency, for sure, but it requires a fundamental rethinking of how we do security. Thank you so much for joining me for this explainer, and I hope this gives you the actionable framework you need moving forward.